So what we've done is we've added a bunch of new features.
Absolutely amazing.
.NET is a general purpose framework for building all of these types of applications.
You can be productive and code and build your UI quickly.
What?
Hi folks, how are you?
And the home screen shows you the sauna temperature.
And you can see down here on the lower right, it now knows the garage door is open.
Let's jump into the code now.
The .NET community has just always been a great community to be a part of.
This really is a state-of-the-art technology.
You can actually download this right now
And get right to the code.
build some new applications on .NET Core.
Please have a great conference. Ask us lots of questions on Twitter. We're going to be there all week.
Welcome to .NET Conf 2022, the biggest celebration of .NET every year. I'm Scott Hunter, VP of Product for the Azure Developer Experience team. But let's talk about .NET. Let's get in here. So we're in the studio. We got the team in the back, all ready to show all the amazing demos of what you can build with .NET 7. And I'm going to start over here and introduce Gaurav Seth, the Partner Director of PM for .NET. Excited to be here, Gaurav.
Yeah, hey Scott, I am so happy to be here with you and everybody else who's joining us this morning. You know, it has been such a gratifying and humbling experience to see all the excitement for this conference and the release of .NET 7, you know, the most productive and performant release of .NET 7 ever.
I'm super excited that I've been doing the keynotes of .NET Conf for the last 7 years, but I'm about to hand over to Gaurav, who is now the Director of PM for .NET. And I am taking over Azure and trying to make Azure the best experience for all of our developers.
Yeah, thank you, Scott, and good luck in your new role. But I'm sure we're going to see you soon.
Yes.
All right. Now, our vision for .NET remains to be the same. Build a unified development platform for developers to build anything with best-in-class runtime, programming languages, development tools, and a vast ecosystem powered by amazing developers around the world. With .NET, you can build any type of application that you need for the devices that are critical to your business and on the operating system of your choice. .NET will run fantastic anywhere and everywhere you deploy. Now let's first talk about the momentum of .NET, and we are growing at an astonishing pace. .NET is used by more than 5.7 million developers, and they are adopting the latest version of .NET faster than ever. .NET 6 has seen nearly double adoption over the same period as .NET 5. Not only are developers adopting .NET, but they also love using it. We again are the top loved framework on Stack Overflow survey. C# is amongst the top GitHub languages, and we continue to be one of the highest velocity open source projects. Now, ever since we open sourced .NET, there have been over 48,000 contributors to the .NET repos. This is absolutely astonishing and humbling. You know, we are truly building this together. Now, every great development platform needs an amazing community and an amazing ecosystem. NuGet is our home for library creators to share with the world. NuGet now has over 320,000 packages that have been downloaded more than 240 million times. We continue to invest in NuGet by listening to our library creators, adding new features they desire, and ensuring that NuGet is the most secure package ecosystem for all developers and enterprises. NuGet now supports features like central package management, two-factor auth, and much more. So before we get into what's new in .NET, you know, I have to say thank you. Thank you to all of you. Every single developer that is building with .NET, building open source libraries, submitting issues, fixing documentation, or helping drive the future as part of .NET Foundation. Thank you. Now let's get into .NET 7, our biggest and most performance release of .NET. .NET 7 is a result of more than 28,000 commits coming from over 10,000 contributors. Now, as we work on .NET, we've always been thinking about what are the most prevalent challenges that developers and development teams are facing today. You know, Satya actually spoke about this just a few weeks back at Ignite, and I think it speaks to so many of things that we thought about while working on .NET 7. Right now, many organizations are asking their developers to help them do more with less. You know, what does this mean for .NET? To me, It means that for every feature we build, make it simple and intuitive so that you can be more productive. And for every workload we support, our performance becomes better and better so that with each .NET upgrade, you see your apps becoming more efficient. Now, performance has always been top of mind for each release of .NET, and .NET 7 is no different. For the last several years, Stephen Tobe has been publishing a blog highlighting the core performance improvements with every release of .NET. With .NET 7, we are delivering more than 1,000 performance improvements, and if you were to print his .NET 7 blog to PDF, it'll be over 200 pages. We will touch on some of these improvements today, but if you haven't read one of these blogs, it is a joy. .NET 7 continues to build on our core promises of a unified development platform for building anything, especially building modern workloads, while making it simple for new developers to learn, easy for existing developers to extend their skills into new technologies, and then the most productive platform to develop with Visual Studio. While these are some of the highlights that we'll touch upon today, there is so much more to .NET that you will see throughout the conference. You can go to get.net/7 to download and get started with .NET 7 right away. Now, one of my favorite things about the annual cadence of the .NET releases is that our programming languages also get brand new productivity feature. C#11 is here along with .NET 7 and brings some of the great new features for developers, including generic math, support for required members, and raw string literals. With .NET, our goal is to ensure that developers have a delightful experience building for the web, be it full-stack web apps or web APIs, building powerful cloud-native apps that scale with your business needs, or building client applications that can run across desktop and mobile devices. We'll cover some of the key features across all these workloads this morning, but you'll hear a lot more about them and their roadmap throughout the rest of the day. So let's start with building for the modern web with .NET. The modern web requires three critical things: a powerful runtime, a capable set of APIs that can power anything, and the elements to create a stunning website. In .NET 7, we deliver on this by adding support for HTTP3, rate limiting, route grouping, and several other improvements across the spectrum for developing web APIs and web applications. There are so many key areas to the web for .NET that right after the keynote, you will hear from Daniel Roth in the State of ASP.NET Core session, where he will go deeper in each of these areas. For now, I will focus on APIs and the investment that we have made in these. Now, when I think of APIs, I think about how they are truly everywhere and powering everything that we do. APIs are mission critical to organizations, small and large. Take, for example, this event. There are several APIs required strictly for bringing the stream to you. However, when you add up the website, social platforms, and the communication stacks, there are hundreds of APIs powering all different types of applications. This is why we care so much about APIs built with .NET. We know they are the backbone to so many amazing applications, and they are truly powering the world and the applications that we all use every day. Our mission is to ensure that APIs are easy to create and maintain, they are secure, they scale, and they are hyper-fast. How fast, you may ask? Well, they are blazingly fast. .NET API performance has been at the top of the charts of Tech Empower benchmark for years. With .NET 7, we continue to push forward to squeeze every ounce of optimization we can, and the team has improved on .NET 6's performance now by reaching over 7 million requests per second, which is around 11 times more than what Node.js achieves on that benchmark. Now, when it comes to throughput, it has been our big focus, and for JSON serialization, we have improved it by about 16% over .NET 6. Now, in fact, at this point, we've hit the limit of the network card that is used to measure these tests on the Tech Empower hardware, which is just incredible. Now, when working with APIs, we know that it is not just about throughput. APIs must interact with the backend services and databases, all of which impact the end-to-end performance. Therefore, we continue to invest heavily in Entity Framework Core, the object relational mapper for .NET that enables developers to interact with a whole wide range of databases, including SQL, Cosmos DB, Postgres, and many more. In .NET 7, we've not only added several new features like distributed transactions and mapping to JSON columns, but have also worked on increasing the throughput of working with data all the way by up to 74%. So things will be more than 4x faster in certain scenarios. Now, even though we often talk about REST APIs, you can build all sorts of different APIs based on what your application needs, including gRPC for hyperfast communication between servers or server and client. With .NET 7, gRPC is now faster than ever. It is not only significantly faster than .NET 6, but also best in class. We are pushing the boundaries of what you can build with .NET and ensuring that it meets your and your customers' needs. Now, with all of these enhancements, it doesn't mean things have to be complicated or hard to get started. We are focused on ensuring everyone can build amazing APIs with .NET quickly and scale to add powerful features as they need them. With .NET 7, building these APIs is lightning fast as we have fine-tuned the framework to help you build APIs that are minimal, powerful, and secure. Now, we've added new features like the Map Group API to easily scaffold out full REST APIs in the most minimal lines of code and enable developers to structure the code more efficiently. Authentication is another key area in APIs that is so important. Based on feedback from developers, we have significantly simplified authentication, making it just a single line of code and a method to call. Well, that was a lot, and it is time to see some of this in action. Now, let me introduce Safia and Julia, who are going to show you some of these enhancements and what else you can do with .NET APIs. Over to you, Safia and Julia.
Thanks, Gaurav. Now, in last year's .NET Conf, we showcased the .NET Podcast app, which allowed users to listen to podcast episodes via a mobile app and a web app. Today, I want to hone in on the API that makes this experience possible and show you some of the new features that we built in .NET 7 to make building APIs fun, productive, and powerful. Now, I'm going to jump into my editor here and show you some of the code for the existing podcast API. One of the things that I'm observing is that the code uses several different strategies for registering routes in our application. Here I see that we have map action calls in our program CS, we have got a shows controller, and we've got some endpoints that are registered under an extension method that is called from our program CS. Now, this is fine. In fact, it's pretty cool because it shows how different endpoint invocations can interop with controller-based APIs. But for the sake of myself and some of the other developers on the team, I want to clean up the code that we have here, make it a little bit more dry and easy to read using a new feature we shipped in .NET 7 called route groups. Now, so we're able to see the before and after code without route groups and code with route groups. I'm going to create a new minimal API project in my solution. Right-click, add, new project. Once I've selected the API option, I'm going to be able to customize a variety of settings in my application. Whether or not I want support for HTTPS, I do. Whether or not I want to enable Docker, I do because it fits into our deployment story. Whether I want to use controllers, I don't in this case because I want to use minimal API-based endpoints for all of our applications. And whether or not I want to enable OpenAPI. Once I've created my application, I want to use the scaffolding tool in Visual Studio to create endpoints backed by entity framework models in our application. So let me go ahead and show you what that looks like. I'll go ahead and right-click, add, new scaffold item. And here is the magic option, API with read-write endpoints using entity framework. Once I've selected this option, I'm able to select a backing model for the endpoints that are going to be generated by my API. Here I'm picking the weather forecast model that's part of the base template. I can choose to generate a new endpoints class, as well as generate the data context classes needed to support my new API. Now, what does the generated code look like? Let's take a look at that really quickly. Aha! This is what I want to see. The generated code is taking advantage of the new Map Group API in minimal APIs. Map Group allows me to create groups of routes that share a common prefix, in this case, API weather forecast. Once I've created this group, I can apply different invocations to it, such as with OpenAPI, or require authorization to add OpenAPI, or add authentication to all of the routes in that group, providing me with a much drier experience for writing code. I love this pattern, and I've honed in on using the scaffolder for all of the different resource types that are defined in our application. Here you can see I've generated a categories API that allows me to generate our get categories route onto a route group. And I have APIs for episodes as well as shows. Now, one of the pieces of feedback that we got from last year's .NET Conf was that users would love the opportunity to submit show ideas that should show up in the podcast app. And to that end, we want to add a new set of endpoints to our application called feeds endpoints that will allow users to submit feeds that they want to show up in their API and allow an administrator to approve or deny feed submissions. So I've gone ahead and written up the code to support this API. I've got one post endpoint, a get, a put, and a delete. With route groups, this code is dry and easy to read, as you see when invoked in my program CS. Now, I want to drill a little bit more into this feeds endpoint and show you some of the new features that we shipped in .NET 7 to make building APIs more secure and reliable. I mentioned that this feeds endpoint will support submissions from external users. Now, I want to lock things down a little bit and make sure that people aren't able to abuse the API. To that end, I've added support for rate limiting in my application using the new rate limiting APIs. Rate limiting allows me to configure rules that will limit the number of requests that can be sent to my application over a fixed time window. Here I'm doing this by invoking the add fixed window limiter option. Rate limiting supports a wide variety of customizations that you'll be able to see later in the conference, but for now I'm getting started with this basic model. In addition to rate limiting, I also want to make sure that only admin individuals can deny or approve feed requests. So I need some sort of way to add authentication into my application. I'm going to leverage Azure AD for this by introducing the Microsoft Identity Web Package and configuring authentication using just 2 lines of code. Here they are. The first line of code enables Microsoft Identity Web-based authentication. The second line of code adds an authorization policy that requires that people be able to present a particular API scope when sending requests to my app. Now, I've talked a lot about the code, but I haven't yet showed you what the API actually looks like when we interact with it. So let's go ahead and run our API. Cool. This is our trusty Swagger user experience that we can use to interact with the API. You saw this in last year's .NET Conf, but I want to draw your attention to this Authorize button in the top right corner of the screen. We've detected or inferred that this application has authentication enabled. And with this authentication enabled, we can provide a bearer token that will be sent for any request transmitted from this UI. But I don't have a token handy to use as I'm testing this API locally. Or do I? In .NET 7, we introduced the new .NET User Dots tool, which can be invoked via the command line to generate tokens for local testing. Here, I'm invoking the .NET User Dots tool to create a token that matches the audience and claims that are expected by my Azure AD provider backend. Once I've acquired this token, I can copy it into my local UI for testing and check out what happens when I hit one of the delete endpoints with some sample data. Pass in an ID, hit execute. We'll observe that the authentication API has sent over the token in the bearer in just a moment. Oh, I know why it's not happening, because there's a breakpoint. We'll hit continue there. Aha, this is what I want to see. We've transmitted our token via the bearer, and here's the expected response. We're able to see the end-to-end of interacting with authentication locally in my application. I'm really excited with what I did with the Feeds API. I've secured it with authentication, and I've ensured that it's resilient against abuse with rate limiting. I'm going to go ahead and deploy this to the cloud. And Julia, I hear that you have some things to show us about how we can supercharge our API when it's in the cloud with Azure API management.
Awesome, and thank you, Safia. So with an API-first strategy, APIs can go everywhere and we can empower everyone. With our next demo, we want to demonstrate you how easy it is to consume .NET REST APIs from different kind of platforms. Azure API Management as our management platform for APIs is one example of these consumers. But we can also light up platforms like Microsoft Teams or the Microsoft Power Platform and enable cross-platform scenarios. So for my demo, I'm going to jump right into my Azure API Management instance. After deployment of our web API, we first have to add our API to our Azure API Management instance. We have lots of different options, so no matter what type of .NET API you're building or where it is hosted. Currently, Safia's web API is living in an Azure Container App, so we were able to import it from one of our Azure resources. So we were able to import it and called podcast.minimal API. Azure API Management then pulls in our API and leverages the names, the tags from OpenAPI. We can also set up a policy to modify our request before going out to our backend service and make it even more secure before other consumers like the Microsoft Power Platform interact with our web API. But before we want to expose it, let me first show you how we can test our web API within the portal. For this, I'm going to hit the testing tab right here, and I'm going to choose the get feeds operation and hit the send button. As you can see, I'm getting a 200 and all of my responses in the body here. I'm going to copy one of the IDs, and now I'm ready to expose it to the Microsoft Power Platform. For this, I'm going to switch over to our Power Platform tab right here. And from here, as you can see, I can easily create a so-called custom connector. A custom connector is basically just a wrapper around a REST API that lets users of the Power Platform communicate with our web API. As soon as I hit the Create button, a custom connector will be created on the Power Platform side. So after this has been done successfully, I can then switch over to my Power Platform portal and under Custom Connectors, see the web API we just exposed. Because we implemented authentication on our API level, I want to make sure this is also configured on the Power Platform side here. And just like Safia, we chose OAuth as our authentication type, and we also selected Azure Active Directory as our identity provider. Now I'm ready to also test it within the portal right here. This time I want to test my delete feeds operation just to make sure authentication also works here. So I'm going to paste in the ID and I'm going to hit the test operation button. And as you can see, I'm getting a 204, so this podcast has been deleted successfully. So now that we tested it in here, let me show you what this will look like if we want to consume a web API from a Power App itself as well. So some of you might be wondering why we are using Microsoft Power Apps. For our use case in particular, we needed an internal application for some of our admins. We chose to use Microsoft Power Apps to get our job done as quickly as possible without having to worry too much about a lot of front end or writing a bunch of code. The important thing is we are able to communicate with our .NET REST API and enhance functionalities of the Power App as well. So before I can make an API call, I first have to make sure we have imported our custom connector. Now I'm ready to make an API call. And this can easily be done by just simply referencing it up here in the formula bar. And as you can see, I'm calling the custom connector's name and the operations name. But let me show you what this will look like in action. I'm going to hit the play button. I'm quickly going to refresh the dashboard because we deleted one of the podcasts while testing. And now if I hit the approve or the delete button, one of the podcasts should be deleted or approved. Here you can see I successfully deleted one of the podcasts. So while testing, I noticed that we are not getting any return message here. So Safia, I was wondering if there's an easy way for us to show any of the upcoming requirements.
Great feedback, Julia. You're right that when a user deletes a feed, they don't get any message indicating that the feed was successfully deleted. So I'm going to head over to my screen here, And you'll see that I've made the necessary updates to the delete endpoint. We're going to return a message now whenever the user deletes a feed. Now, usually if we were going to test this, Julia, we would have to deploy to staging or production and go through a whole process just to validate that my change works. But there's something new in Visual Studio that I want to use that I think will help us out here. It's called dev tunnels. I enable it by setting some flags in my launch settings. You can see them here. And what's going to happen is as I'm running my application, I'm going to get a unique URL. When you access this URL and send requests to it, they're actually going to be tunneled to the API running on my local machine. So we'll able to see the interaction end to end. And in fact, I want to test this out right now by setting a breakpoint in the API that I just changed, which I hope will be hit. And I'll go ahead and share that URL with you over Teams. Let me know when you've got it and we can try this out.
Yeah, awesome. I got it here. I'm going to switch back over to my Azure API Management instance and change one of my backend runtime URLs. So I'm going to replace the current runtime URL, and I'm going to paste in the DevTunnels URL here. I'm going to hit the Save button. And now I'm going to switch back over to my Power Platform portal here.
Yeah.
So as soon as I'm also going to copy one of the IDs you shared with me earlier. So as soon as I should hit the test operation button here, we should hit a breakpoint on your machine.
Yes.
Are you ready?
I'm so ready. Here we go. I've hit my endpoint. Is the feed that you deleted one that begins with B57?
Yes.
All right, Julia, so you should get a string back. I'm going to hit continue on my local editor here. Let me know if the message you get back looks good.
Yes, awesome. I can see a 200, and I can also now see the return message here right in my body.
Sweet.
So with the DevTunnels in Visual Studio, Safi and I were able to collaborate even faster. We connected Safia's web API running on her local machine to my web service by just copy-pasting the DevTunnels URL. DevTunnels enable developers to create an endpoint to their local machine and generate and provide a seamless debugging experience for Power Apps, webhooks, Blazor web applications, and many, many more. With just a few configuration settings, you can enable this. And now back to you, Gaurav.
Yeah, thank you, Safia and Julia. It is incredible to see all these enhancements in action. And just to summarize, I think you were talking about dev tunnels, and how they make the developers so productive while working with APIs. Now, it is incredible to see all these enhancements in action and how .NET 7 will enable developers to build rich and powerful APIs. Now, we want every developer to be able to take advantage of these new features, which is why we are on a mission to help developers easily upgrade to the latest .NET. We have built several tools to assist with the process. First is a tool that enables you to incrementally upgrade from ASP.NET Framework to ASP.NET Core. This tool helps you set up an ASP.NET Core app in front of your existing ASP.NET Framework app using YARP or yet another reverse proxy, and helps automatically route requests between the two. You can move endpoints and pages to the ASP.NET Core app one at a time while you continue to develop and maintain the existing functionality. Now, for a wider range of .NET applications, you can use the .NET Upgrade Assistant. That is being used by more and more developers to move to the latest version of .NET. The Upgrade Assistant is built in the open, and in .NET 7, we've added support for new app types, new analyzers, and so much more. There is really no better time to upgrade than now. Now, throughout the year, teams across Microsoft have been sharing these stories about their migrations to the latest version of .NET, the performance gains that they have seen, and all the savings that they have been able to leverage by upgrading to the latest versions of .NET. Now, I want to tell you about one of these stories, about Microsoft Graph as they migrated to the latest version of .NET. Now, Microsoft Graph is an API gateway that provides unified access to data and intelligence across the Microsoft 365 ecosystem. The service, as you would imagine, needs to run at scale and at a very, very high scale, right? 4 years ago, they were on .NET Framework, serving around 1 billion requests every day, but had extremely high operational costs, so they started migrating, first from .NET Framework to .NET Core 3.1, then to .NET 5, and currently they run Microsoft Graph on .NET 6. Today they serve a staggering 70 billion requests per day. That's almost a 70x increase. Additionally, the operational costs were reduced by about 91%. With every upgrade, they saw improvements, but the biggest gains came from that first move from .NET Framework to .NET Core. Now we want you to take advantage of the similar benefits for your .NET projects. Upgrade to .NET 7 today. Now this is just one example, and I encourage you to read a lot more stories from teams here at Microsoft and companies across the world that are building with .NET. And if you'd like to share your story, please do reach out to us. Now, one of those companies is the world's largest scavenger hunt, Geocaching, headquartered right here in Seattle. You may have heard of geocaching, or maybe are a hardcore cacher yourself, but did you know that .NET powers geocaching, the game and the company? They have chosen .NET for over a decade and continue to invest to stay current to take advantage of everything we have talked about today. We had a chance to speak with them recently to tell us more about their .NET journey and how .NET APIs have enabled them to grow and scale over the year. Let's roll the video.
Geocaching is a game of hide and seek where people place boxes around the world and other people try and find them. Geocaching started in a basement. There were 3 of us that founded the company.
It was a web-only experience. We had GPS devices that we would use in the field.
When mobile came around,
we grew from serving thousands of people to now millions of people. We had to learn how to scale really fast. .NET allowed us to build web APIs to scale our website so we could serve customers as we grew. Now, our entire backend is built with .NET web APIs.
Our API supports millions of customers around the globe, and it's 24/7. That's actually more than 1,000 calls per second. We have over a billion of geocache logs recorded in our system. Our API supports over multiple dozens of partners, as well as our internal client, including our mobile app and our websites.
It's always been really easy for us to upgrade .NET. We've had good luck with LTS versions and also non-LTS versions. They both tend to work seamlessly. I'm really excited about the .NET 7 release. I know there will be improved security, there will be improved performance, new tools, and just an overall better coding experience.
.NET has been the cornerstone for us because it's been helping us grow and scale along with our customer base.
It's reliable, it does what I want it to do, it's secure, everybody knows how to use it, it performs. It's my favorite platform.
It is incredible to see what developers across the globe are building with .NET. And now to tell us more about how developers can build scalable cloud-native applications, I have my friend here, Scott Hunter, to tell us more. Scott, over to you.
Thank you. Cloud-native is a term you hear all the time today, and we're here to tell you that .NET is the best tech for building cloud-native applications. So let's go forward here. So basically, we estimate that by 2024, over half of the companies out there will be building apps using cloud-native technologies. This means that you can build apps that can scale to meet any demand. It means that your apps are super resilient, and it means that your apps can be built faster and faster. Cloud-native apps. So 60% of apps, developers are using containers. We're going to talk a lot about containers because I'm a big fan of containers here, and .NET is amazing for containers. Backend developers are using cloud-native technologies, 41%. And then 66% of cloud-native developers are building microservices. And .NET is great for all of these things. Whether you're building containers or Linux support or APIs, we are one of the best technologies for that. So what I want to talk about now is show you Canonical and their support for .NET. Let's roll the video, please.
Developers want smaller container images to use in production. They want higher performance, lower cost.
We wanted to reimagine containers as being super stripped down, appliance-like. And so we came up with this idea of chiseling. You just grab .NET on Ubuntu, build an application, and then turn around and chisel it, get rid of everything that you don't absolutely need for that production environment, but still leave those slices in the chiseled Ubuntu container, which support the production runtime use case. So small containers enables cloud native developers to build applications that can be deployed faster and scale much faster. It's also more secure because there's less in it to attack, and it's going to use fewer resources. It's going to be more cost effective. It's going to use less energy.
We also set up a zero distance secure supply chain, and it gives you an additional level of security. Now, Canonical drives VM images and container images to Azure, and then on their way back, they take all the .NET source back to Canonical so they can build the .NET packages. .NET in Ubuntu is updated on the same schedule as everything else, and then no one gets 0 day.
And the teams are working together to make sure that .NET 7 is available right now to open source developers on Ubuntu. .NET is, for me, a platform that will unlock the next generation of applications. It feels like now Ubuntu really does everything that a cloud native developer needs to kind of bootstrap and be productive.
So that's amazing. So think about this. .NET is now in the box in Ubuntu. Starting with Ubuntu 22.04 LTS, you can basically apt-get or apt-install .NET into that. What you get, you're getting enterprise-level support for Ubuntu. You're getting same-day update for patches. We have support for both x86 and ARM64 in Ubuntu, in .NET 6 today, and .NET 7 is right around the corner. And so I'm super excited about this. I mean, .NET doesn't just do Windows, .NET loves Linux. Even better, if you're building containers, which is the form of all future deployment to the cloud is going to be containers. And if you look here, we support .NET and chiseled Ubuntu containers. What are these? These are distro-less images. So it's the smallest size container you can get here. Why does that matter to you? Quicker to pull, quicker to deploy, quicker for all of those things. Also, these are the most secure containers you're going to get because there is no shell, there's no package manager, there is no root user. We've ripped all that stuff out. It's just your application. And you can see here on the graph, look at that, 104 megs for ASP.NET web application running in the containers. And something else, we are living in a world right now, ARM64. It's everywhere. Whether it's an Apple M1 Mac, we just announced the Volterra development machines a few weeks ago as well for Windows. ARM is everywhere, and we want to make sure .NET runs best on ARM. So you can see here, we have our performance is on par with x64. We have native support in Visual Studio. You can actually now download a Visual Studio and run it on an ARM64 Windows machine, and it will just work as native ARM64. We have native support for .NET Framework 4.8.1. So even if you're on the older technologies, it doesn't matter. Your applications are completely able to run natively on ARM. And then basically, .NET scales to wherever you want. You can see from the charts here, tech-empowered JSON support is just as effective on ARM as it is on x64. The latency is just as good on ARM as it is on x64. So you can see our continuing investment to make .NET work everywhere the best that it can. And of course, we love containers. I love containers. One of my favorite features of .NET 7 is the built-in support for containers. It used to be that you had to turn Hyper-V on a Windows machine. You might have to install Docker for desktop. We don't want you to do any of that stuff. We want containers to be as simple as doing a .NET build. And so you can see on the command line here, I'm basically doing a .NET publish, and I'm telling it to use a publish profile that tells it to build a container, and it'll just build you a container with nothing else on the box. And so our goal here is not only to let you have great support for Linux in .NET, but to make it so it's as simple as building a regular app on your machine to build a container. We're trying to take all that work out and make you more productive. And with that, I want to hand off to David and Chet, and they're going to do some amazing demos of containers in .NET.
Thanks, Scott. Couldn't be happier to show this off. I'm super excited for this feature as well. Containerizing can sometimes be difficult, as Scott said. There's a whole bunch of knobs to get right. The good news is the .NET SDK knows most of these knobs already, so we can help you package your container quickly, easily, and effectively. With some new APIs that came in the .NET 7 runtime, we can even do this without any external tooling. Let's see what this looks like on an actual application. So in my PowerShell session here, I'm in the .NET podcast application that Sophia showed a little earlier. It's been rewritten to use some of the new features in ASP.NET on .NET 7, And because of that, we can use our new containerizing features. This is the command that does the deed. Let's run it and see what we've got. So all of this should look very familiar at this point. It's a normal build, but wait, look at all of this output. You're seeing things like image names. You're seeing things like tag versions. You're seeing things like base images. These are all concepts that should be familiar if you've containerized before, but they're happening inside the .NET SDK. And then later on, you can see that we're uploading these things called layers to a registry. This is everything that you may be used to with other containerized or containerization technologies in one command. And even bonus, look, no other applications running. That's crazy to me. Let's look at what it what you have to do in your projects to get this up and running. So like I said, we are in the minimal API project on the .NET Podcast application. Let's take a look at our project file. We'll clear out some extraneous information and look at the core pieces of it. So this functionality is delivered through a package reference right now. This package is called Microsoft Net Build Containers. You can add that through the NuGet UI in VS, through .NET Add Package, or any other way that you're used to adding packages. Once you do this, you will get access to that publish command that I just ran. And if you don't specify anything else, we will infer all sorts of information about your project to pick the correct base image, the correct container name, and then we will publish that to your local Docker daemon. So by default, you get something that you can run and you can verify. But you are in full control here to customize all of those parameters as well. The image name, any tags that you want, even the registries to upload to. And if you choose to upload to a registry, the SDK is there for you. It will understand all of the existing Docker authentication mechanisms that you're used to, and it will take that information and authenticate to those registries to do that upload. In fact, that's exactly what we saw here on the command line. Before we started, I'd logged in with ACR login to my Azure Container registry, and that's what made this push happen. So for right now, you have to add this package reference, and that's a bit of a step. So what we're looking for in the future is to bring this functionality directly into the .NET SDK. We're also looking at expanding our support for the kinds of customizations that you can do, specifically around users and groups in the containers. And this will really unblock our full support for those chiseled containers that you heard about earlier. We will also be looking at expanding the set of authentications that we understand so that we can more fully support the broad array of registries that exist. So that's the core technology. But let's look at how Visual Studio can build on that to deliver a compelling user experience for the tens of thousands of Visual Studio publishes that you all do every year. So we have our application here, and we can do the right-click publish gesture that we're used to. And we can make a new publish profile for this. And because this application is Dockerized, pushed to Azure Container Registry, and then deployed in Azure Container Apps, we want to see if we can do that automatically as well. So some of you may have seen this flow before, but we are going to choose the Azure Container Apps workflow, and we're going to pick some of the existing subscriptions and some of the existing Azure Container Registry registries to push to. Oh, whoa, this is new. This is different. I have a choice now. I can containerize using the .NET SDK tooling, and VS is telling me it will understand that. So let's do that. And then let's do a CI/CD workflow. When we generate this workflow, we'll go through it, but what this will do is give us a firm foundation for our entire team to build upon. So what we'll see here is a full-featured foundation. This is going to push on every or it's going to run on every push to main, and it's going to do all of the, so many steps that you have to do to correctly log in and containerize and build your application. So it's going to log in to that Azure Container Registry that we chose before, and it even has done the hard work of acquiring the secrets necessary to make that work. And then it's going to do the publish, which looks very similar to what we just did on the command line here. Even specifying the same profile, specifying a custom tag to make sure that we don't overwrite the tags, and then specifying the registry. So it knows how to use this new technology effectively. And then it will, then continue on to actually trigger an Azure Container App deployment of that container instance that we just pushed up. So one thing that we can do is we can actually go see the container in the registry. And we can verify that that push that just happened did in fact happen. So if we go to our container registry and we look at our repositories, and we can look at the podcast API, and we can see that 1.0.0 was pushed up just a minute ago. That's fantastic. So we've shown how we can containerize, and we've shown how we can generate a good CI/CD workflow as a foundation for our team. I think we're done. I think we've published. Let's go see what things look like in the real world. David,
Awesome,
you want to take a look?
So now I don't have to learn YAML anymore, right?
No,
It's awesome.
you don't. It's amazing.
Cool. So
Just XML.
the app is deployed. It's in Azure. We should be done. We can go home with our lives, be done with the keynote, and be over. Let's make sure it scales for when the app goes viral. I'm going to run a load test right here in the command line. I'm going to hammer the backend API with a bunch of load. Let's see if the app still works while it's being hammered with load. I'm going to try to sign in, and sign in, and sign in, and hopefully, eventually it will work. It seems like the app is dying. This isn't great. Our cloud-native web scale app isn't working at scale. Let's try to figure out what is happening. I'm going to open up the Application Insights dashboard to get an overall view of my application's health. You can see here I see a bunch of failed requests. That's not great. I'm also seeing the server response time going up really high. In fact, as high as a minute. The app is actually still spinning. Not great. Let's dig in and see if we can figure out what's happening with the application right now. The server response time shows me an overview of all the slow requests in the application. You can see the shows request seems to be the slowest, as slow as 12 seconds. So we have 14,000 samples of this request. We don't sample every request. That would be very slow. We pick a subset of those requests to sample. And I can dig into this request, the shows request, and try to find a good request to zero in on so we can see what's happening with the application. Why is it slow? 1.7 minutes. That is insane. Let's see if we get a good trace here. Oh, this is a good one. OK, so I'm going to minimize this. And we can see here a distributed trace of the shows request showing me all the requests to the backend database, and for some reason, a bunch of requests to other endpoints. I'm not sure what this is, but this gives me a big clue as why it's slow. Top10devs.com apparently failed. So we have one clue so far. We have this trace. Let's see if we can find more information to figure out what could be happening with the application's performance. Now I have a second dashboard here that I made called .NET Performance Dashboard, which is going to show me all the metrics for my application. So I have the threads and thread pool. I have the ASP.NET Core requests, info about the garbage collector, and locks. Now, I see that whenever there's a spike in requests, it tends to correlate with a spike in threads. That's the opposite of scaling cloud native. What I want is my threads to be low when the requests are high. I need more money, more users, and I want my app to perform well. So we have our second clue. We have metrics that are showing high threads, and we have the trace showing slow requests. Let me show you how we actually turn on these metrics for the application. If I go to the code in Program CS, you'll see I have wired up OpenTelemetry, which is an open source library that is used and becoming the industry standard for how diagnostic information gets from applications into tools. I'm configuring distributed traces, metrics, and logging, and I'm saying where I want it to go, Azure Monitor, and what I want to collect. So I'm collecting HTTP client information for outbound requests. I'm collecting stuff for the database and for ASP.NET Core inbound requests. So you can see this pattern for tracing, for metrics, where I'm also sending to Azure Monitor, and I'm sending it to Prometheus, which is an open source database for metrics. And I'm collecting all the information required from the application and the core runtime libraries so we can get info about how to debug the application. Last but not least, I can send fully structured logs to Azure Monitor by configuring logging to be sent there. So I have distributed traces, metrics, and logging, but I still don't know what's happening in the application. So we have 2 clues, but we need to figure out exactly what's happening. So what can I do? Good news, Chet setup, good job, Chet. Chet setup on Azure Container Apps, a sidecar container .NET Monitor that we're going to use to collect deeper information from the running container in Azure Container Apps about what's happening. So we've configured a bunch of environment variables, are kind of boring, it's kind of insane, that will collect a process dump and collect all the stacks from the application, the API, whenever we see a high thread pool queue length. The graph we saw earlier showed a super high queue length of I think 300. So when it's over 10, for more than 10 seconds, we want to collect information to do a deeper diagnosis. Now, when you collect a dump, they're typically huge, massive, right? Could be gigs in size. I want to show you an example of that, actually, if we go into blob containers. So we're sending these dumps and stack traces to Azure Blob Storage. And if you look at the size of these dumps, they're gigs in size. So that's a small one. The big ones, if I start by size, that's not the size I want.
Descending.
Oh yeah, so a 2 gig dump for this very small application. So typically you don't want to pay for bandwidth to actually get these dumps to my local machine. So I can use stacks to quickly diagnose what might be the issue in the cloud. I actually did it beforehand. I actually have a dump in VS Loaded for the keynote, obviously. And I'm going to run an analysis on this dump to hopefully figure out what's wrong. All right, so this dump came from the Linux container, and I put it onto a Windows machine, and we're going to put it into VS, and we'll see what happens, right?
That's mind-blowing to me.
All right, so now I'll click Analyze, and it's going to run, and it will run a bunch of rules over the dump. And it says there's a blocking call on the thread pool that may cause starvation. All right, so VS told me there's 78 threads blocked in this method, the shows API, where we had a hunch, right? I think it was wrong. And it says this may cause thread pool starvation and hangs. So I'm going to click here, and it's going to pinpoint the exact line of code where the issue is. And of course, when we're getting all the shows, we're making a request to make sure that the shows link is valid every time it happens for every single show. Not great. But then we're also doing .result, sync over async. This is the issue. So I should be able to delete this whole line because we should be checking the show link on ingestion, not on read.
I'm just going to say, don't get blamed that line of code, please.
I won't blame you on stage. So yeah, so that's it. I should debugging now. And that was the whole thing. So we saw you build a container without a Docker file. We saw me diagnose a production application with OpenTelemetry support. And finally, we used VS to pinpoint the line of code where the issue was. That is the power of cognitive.NET.
Oh, yeah.
Back to you, Scott.
Thanks, that was amazing. And just to recap, .NET loves Linux. We just said that we're now in Ubuntu. We're also in Fedora. We're also in Red Hat. And so you can see the Linux community is embracing .NET. We just showed not only can we run on Linux, but we have great diagnostics on Linux as well. And then finally, we showed that .NET loves containers. We have great support for no longer requiring you to put a Docker file in. You can just publish your app right to any of the container things that we have in Azure. And if you look, Azure is the best cloud for running cloud-native applications. But I want to focus on just what we do for containers. We have a couple of ways of hosting your containers of .NET in Azure. Number one, App Service. We have App Service can run Windows containers and Linux containers. Then we have Azure Kubernetes Service. This is if you want to have massive scale .NET running in Kubernetes, we support you there. And then finally, we have the newest edition, which is Azure Container Apps, which still runs on Kubernetes, but we actually manage that for you, and you just focus on your applications. And with that, I'm going to hand it back over to Gaurav to talk about the rest of what's new in .NET 7.
Yeah, thank you, Scott. This is I just want to finish this morning by talking about our investments in enabling developers to build client applications across mobile and desktop. Now, .NET MAUI is a unified development framework for .NET to build beautiful cross-platform apps for iOS, Android, Windows, and Mac all from a single shared C# code base with access to native platform APIs and delivers native performance. We continue to rapidly iterate, bringing several enhancements to .NET MAUI in .NET 7, and I encourage you to see the State of the .NET MAUI keynote later today to catch up with some of those enhancements. Now, we released .NET MAUI earlier this year at Build, and it has been really fun to see what you all have started to create with this platform. The ecosystem around .NET MAUI is starting to flourish with community packages and amazing control vendors enabling developers to build beautiful applications. We are also starting to see companies around the globe trying out .NET MAUI to adopt it as their multi-platform framework of choice, including teams internally at Microsoft. Now, for building client applications, developers like to have choices. Selecting the right stack often comes down to reach versus depth, and it's a sliding scale. .NET supports this entire spectrum. Today, Blazor allows you to build full-stack web applications like PWAs with .NET, with a choice to have the code running on the client via WebAssembly or on the server. With .NET MAUI, you can build native cross-platform applications across desktop and mobile. And now you can also build hybrid client applications that bring web and native together by using Blazor alongside MAUI, all with .NET. We are continuing our investments in all of these key areas, so no matter where on the sliding scale you want to be, .NET has you covered. Now, as I mentioned earlier, we are doing something really special at the conference this year, which is the introduction of State of the Platforms. Throughout the day, you will hear directly from the product teams behind ASP.NET Core, .NET MAUI, and Azure for .NET in mini keynotes to go over topics in even deeper detail. I hope that you will watch these State of the Platform talks, and of course, all the amazing talks here at .NET Conf over the next 3 days from teams here at Microsoft, as well as our global .NET community. Now, alongside the release of .NET 7, we have also released the 17.4 version of Visual Studio 2022 with support for .NET 7 and the latest C# 11 features. It comes with improved performance, AI-assisted programming, and deep integration for cloud-native development. If you're developing on ARM64 devices, this release has full ARM64 support as well. Now, version 17.4 of Visual Studio for Mac 2022 is also shipping today with tons of great enhancements for .NET developers, including the finalized tooling to support .NET MAUI. You can go to visualstudio.com and download it today. Now, let me close this morning by thanking each and every one of you, whether you are already building on .NET or are just thinking of getting started. You can go to get.net/7 to download .NET 7 today and get started with building amazing applications. Thank you so much and have a great .NET Conf.